Hey there, we're going to look at 6.6 and 6.7 today on the properties of logarithms and common logs. And so you'll see the objectives here for those four sections: being able to simplify and evaluate expressions using the properties of logs, solving logarithmic equations using the properties, solve exponential equations and inequalities using common logs, and to be able to evaluate logarithms using the change of base formula. And this falls under a couple of standards. One is an Algebra 2 standard, being able to solve equations and inequalities, and the other is a pre-calculus standard, being able to express logarithms as a solution of an exponential. And that's kind of what this leads towards as we get into further courses. And so we're going to start with three properties here. The first being the product property of logarithms. And the product property of logarithms says this: the logarithm of the product is the sum of a logarithm of its factors. And so as long as a, b, and x are positive and the base of the log is not 1, if I have two things being multiplied together, it'll be the sum of those two separated out. So for example, if I have log base 2 of 12, I could separate that out to log base 2 of 3 plus log base 2 of 4. Okay? The quotient property is the same, except instead of a sum of the logarithm, it'll be the difference of them. And obviously here, we're going to make this correction in the notes right now. This is not the product, but this is the quotient of the logarithm. And so what we'll see here in this is that if for positive numbers a, b, and x, again, x not equal to 1, log base x of a over b is equal to log base x of a minus log base x of b. And so if I have log base 5 of 3/4, we can rewrite that as log base 5 of 3 minus log base 5 of 4. The third property we're going to look at is the power property of logarithms. And if I have an exponent, then that exponent will be able to just come out front. And that's what this property says here. For any real number p, and b and m are positive numbers, b not equal to 1. So the base is b, the m is what we're taking the log of, and the p is the power. The power is literally just able to come out front. So if I have log base 2 of 4 to the 5th, the 5 can come out front and be a multiplier for the next step. Okay? And so let's see how these properties get used in the next couple of examples. And so use log base 4 of 3 being 0.792 to approximate the value of log base 4 of 48. Well, if I know that 3 is this, right? So 0.792. And 48, right? So I can rewrite this problem as log base 4 of 3 times 16. And so that will rewrite as log base 4 of 3 plus log base 4 of 16. And I know that log base 4 of 3 is 0.792 approximately. It's an irrational number. And then log base 4 of 16 is going to be 2, right? Because 4 squared is 16. And so my final answer here is that this is going to be 2.792. So log base 4 of 48 is approximately 2.792. Okay? As we look at example B, the pH of a substance is defined as the concentration of hydrogen atoms, represented by H positive, in moles. It is given by the formula that pH is equal to log base 10 of 1 over H positive. Find the amount of hydrogen atoms in a liter of orange juice that has a pH of 3.2. And so we're going to plug this in and then simplify. So we're going to get 3.2 is equal to log base 10 of 1 over H positive, right? And so this is our quotient property. So I'm going to get log base 10 of 1 minus log base 10 of H positive. And so I'm going to get 3.2 is equal to this is equal to 0, right? Because 10 to the 0 is 1, so 0 minus log base 10 of h positive. So 3.2 is equal to negative log base 10 of that. And don't forget the negative here. Oops. I already had the negative. 3.2 is equal to negative log base 10 of h plus. And so the question becomes, right, remember that logs are exponentials, right? So we could rewrite this as 10 to the 3.2 is equal to h positive, right? And so what is 10 to the 3.2? Well, you break out your calculator. And 10 to the 3.2 is 1,584.89. 1,584.89, approximately. And I know things are a little sloppy here. That's because my stylus is broken. I'm having to do this on my iPad. If you can't tell, that everything looks a little bit different here. And so again, use the properties that we've talked about in this unit to solve this one. Okay? All right, so let's look at C. Log base 5 of 8 is approximately 1.292, and we want to approximate the value of log base 5 of 512. And so with this one, again, knowing how 8 is involved with 512 is important, right? Because 8 to the third is 512. And so that 3 will be able to move out front, and so it'll be 3 log base 5 of 8. And we know that log base 5 of 8 is 1.292. And so we're going to get 3 times 1.292. And that's going to be equal to 6. That's 27. Carry the 2. And that's going to be 8. And so that's our 3. So 3.876 is equal to log base 5 of 512. And again, if you think about the powers, right? 5 to what power is going to give you 512? Well, 5 to the fourth is 625. So 5 to a little less than 4 should be 512. Okay? And so that was example 1. Example 2, solving logarithmic equations. And so in this example, what we're going to see is using our properties to simplify this to the best of our abilities. Okay? And so what we're going to see here is we have 4 log base 2 of x minus log base 2 of 5 is equal to log base 2 of 125. And it is very important here that the bases are the same, because if they're not, we cannot combine them. And so, what we get here, right, this is a division problem, right? And so we're going to get 4 log base 2 of x over 5 is equal to log base 2 of 125. And then the 4 comes up here, so I get log base 2 of x over 5 to the 4th is equal to log base 2 of 125. Now, if I have two logs that have the same bases, then these parts are going to be equal. So I get x over 5 to the 4th is equal to 125. And then I would need to take the 4th root of both sides. And so we're going to get x over 5 is equal to the 4th root of 125 is not a pretty number. And so we'll hold that there for a second. We'll multiply both sides by the 5. And so we're going to get that x is equal to 5 times the 4th root of 125. The 4th root of 125 is going to be somewhere between 3 and 4. Because 3 to the 4th is 81, and 4 to the 4th is 256. And so this is going to be 3 point something times by the 5. And so x is going to be approximately, and again, we could go and actually figure this out real quick. And so 5, clear what we had, 5 times the 4th root of 125, oops, that's not in the right spot, 125 is 16.7. And again, that would be that 3 point that we had times by the 5. So 16.7185. 16.7185. They didn't tell me how many decimal places to go to here, so again, rounding to 3 or 4 places would be appropriate. All right, so let's talk about common logs. A common log is a base with base 10, so log base 10 of x is called the common log, and it's generally written without base. Now, if you go on your calculator, you're going to see a log button. That is the common log. It is log base 10. And so when you go on your calculators and you type log of 22, you're literally doing log base 10 of 22. You just don't have to type the 10. And so let's look at that here. So if I do log of 22, we see that it is 1.342. And again, it's nothing crazy here. So this is approximately 1.342. We can do the same with our second example here. Log of 0.2, and again, that just is base 10. And so, trying to get this to come to the side here. If we change out that 22 for 0.2, we're going to get negative 0.698. And so this is approximately negative 0.6989. So 6990 with rounding, right? Okay. That's it. I mean, it's just going straight to the calculator and doing those. There's nothing crazy. All right, so let's look at example 4. The loudness L in decibels of the sound L is equal to 10 log I over M, where I is the intensity of the sound and M is the minimum intensity of sound detectable by the human ear. The sound of a jet engine can reach 125 decibels. How many times the minimum intensity of audible sound is this? Now, for these type problems, we're going to assume that M is equal to 1, because the minimum intensity being the softest it could be. Right, so we're going to get 125 is equal to 10 log of I over M, but remember we said the M is 1. So we get 125 is equal to 10 log of I. We can divide both sides by the 10. And so we get 12.5 is equal to log of I. Now remember, these are in base 10, right? And so dealing with this would be 10 to the 12.5 would be equal to I. And if we do our calculation there, we're going to get 10 to the power of 12.5 is 3.16 times 10 to the 12th. And so that means, so if we write this answer, 3.16 times 10 to the 12th. If we think about what that means, it is 3 with 1, 6, and then there's obviously other decimals here, but it is 12 decimal places behind the 3. And so this is thousands, millions, billions. This is 3,160,000,000,000 times louder than the minimum intensity of audible sound. And so again, it would be this value here is the number of times louder that it is. All right, let's look at example 5, solving exponential equations and inequalities using logarithms. So in example A, we're going to look at 7 to the x is equal to 29. Now, we could try and get this x down by using a log of the same base, but the other side's not going to simplify nicely for us. And so we need to use a common log that will work for both. Because if I use log of 7 to the x is equal to log of 29. And again, I can take both sides to a log, because remember, what I do to one side, I have to do to the other, right? This x is now able to come down in front, and I get x log base 7, log of 7, not log base 7 here, is equal to log of 29. And then I can divide both sides by log of 7. That part cancels. So x is equal to log of 29 divided by log of 7. Now, knowing that, we can go to our calculator and take log of 29, and we can divide that by log of 7. And we see that it is 1.7304. So x is approximately 1.7034. And so that is one method. We have a second method that we'll talk about once we get through change of base here with the example 6. All right, let's look at example B. Solving 3 to the 7x is greater than 2 to the 5x minus 3. And so we're going to use the same idea here. We're going to take log of 3 to the 7x is greater than log of 2 to the 5x minus 3. And so the powers are going to come down. And make sure that you put these in parentheses here. This will be important for our next step. Now, this is distributed, right? This can distribute to both of these. And so I've got this 7x log of 3 is greater than 5x log of 2 minus 3 log of 2. Now I can subtract this piece across the equal sign. And so what I'm going to end up with is 7x log of 3 minus 5x log of 2 is greater than negative 3 log of 2. And I know this looks a little complicated, but it's going to get cleaned up in a second. And so now, out of these two, I can factor out the x. So I get the x, and I'm going to get 7 log of 3 minus 5 log of 2 is greater than negative 3 log of 2. And then I can divide this back across. So I'm going to divide by the 7 log of 3 minus the 5 log of 2. Love you, boo-boo. And it's Daddy. See you in the morning. Minus 5 log of 2. All this cancels. And so we get that x is greater than negative 3 log of 2 over 7 log of 3 minus 5 log of 2. And I know this looks crazy, but you've got a log here, and a log here that you can calculate on your calculator and get the decimals. And so in the end, we're going to end up with x is greater than. And this at this point, this is where you go to your calculator and you let it do the hard work here. And so it is negative 3. And make sure we get our parentheses right. Negative 3 log, not absolute value, log, negative 3 log of 2, close parenthesis, divided by parenthesis, and it was 7 log of 3, close parenthesis, minus 5 log of 2. I close all those parentheses, and we see that our answer here is negative 0.4922. Again, negative 0.4922. So x is greater than negative 0.4922. Again, it's not the prettiest thing in the world, but it's how we get there. All right, last thing we're going to look at is the change of base formula. And basically the change of base formula says this: as long as I don't have that a or b is equal to 1 in this problem, if I have log base a of n, I can convert that to a new base by keeping the n in the numerator and the base will be in the denominator. So let's look at a really simple example here. If I have log base 2 of 3, let's say I want to convert this to the common log to make it easy for me to calculate, then I would change my b to 10, and so I would get log base 10 of 3 over log base 10 of 2, and I could go to my calculator and now calculate this, right? Because this is just log of 3 divided by log of 2. Okay, and that's another way that we could have solved these problems up here, is we could deal with those logs that way. All right, so express log base 4 of 120 in terms of common logs, and then round to the nearest 10,000th, which is 4 decimal places. And so again, we want the common log, remember, which is base what? Base 10. And so we're going to get log base 10 of 120 divided by log base 10 of 4. And we can go to our calculator at this point and calculate what these will be. And so doing that, we're going to get log base 10 of 120, closing parenthesis, divided by log of 4. And we see that that is 3.4534. Again, 3.4534 is the answer there. 3.453. And again, this is approximation. And so that's it, y'all. I know this is kind of a long lesson today, but this sets us up for the rest of this week to finish out logs and get us to that unit test on Friday on this. And so if you have any questions, my office hours will be a little bit different today. It will be 10 to 12 and 3 to 4, just because I have something going on in the middle of the day that I can't just do 11 to 2 today. So again, 10 to 12 and 3 to 4. And then on Tuesday this week, my office hours will be from 3 to 6, as I will be cleaning out my classroom on Tuesday, which is not something I'm ready to do yet because, wow, this year is almost done. And so with that being said, stay safe, y'all. Stay healthy. Do what you need to do to keep your social distancing up. And so with that, that's the end of this lesson. Again, if you need me, you know how to get a hold of me. Y'all have a great day.